Coordinates of the two opposite vertices of a rectangle are given as 1, 2 and 5, 5. Suppose the other two vertices lie on the line x equals to 3. Then determine the equation of the sides of the rectangle. So let's try to understand the problem graphically first. So here we have the coordinate axis. We have the x-axis and the y-axis. So let's first plot the 2 points 1, 2 and 5, 5. So let's say we have the point A corresponding to 1, 2. Then we have another point which is B, let's call it C, with coordinates 5, 5. Then we'll also consider a line, a vertical line, which has the equation x equals to 3, because any line x equals to 3 is a line parallel to the y-axis, so it's going to be a vertical line. So the line is going to pass through the point x equals to 3. So here we're going to consider a point B which lies on the line x equals to 3. So let's say it has the coordinates 3, y, 1. And we have another point D. D is also going to lie on the same line x equals to 3. Its x coordinate is going to be 3 and the y coordinate will be 2. Now what we'll do, we'll join points A, B, C, D to form a rectangle. So we have the rectangle A, B, C, D. Our task will be to determine the equation of the sides of the rectangle. To do that, what we have to do is we'll have to find out the values of y1 and y2. And then we can use the 2-point form to find out the equation of the diagonal. So let's join point A and C to form the diagonal of the rectangle. We already have BD. BD is the diagonal of the rectangle. We join A and C to get the second diagonal. Now we know that the diagonals of a rectangle bisects each other. So let's suppose that AC and BD bisects each other at the point E. Then we can find out the coordinates of point E. Now because we have the endpoints, coordinates of the endpoints A and C, we can find out the coordinates of midpoint E. So coordinates of the midpoint, coordinates of E, that's going to be equals to, all we have to do is to find out the x coordinate first. We'll add up the x coordinates of point A and point C. So that's 5 added to 1 and we're going to divide it by 2. Then to find out the y coordinate, we're going to sum up the y coordinates of point A and point C and divide by 2. So that's going to give us 3, 7 over 2. So that is the coordinate of point A. Now also, E is going to be the midpoint of BD. Since E is the midpoint of BD, then again by using the midpoint formula, we can find out the coordinates of the midpoint E, but this time we're going to use the coordinates of point D and point B. So for the x coordinate, we take the sum of the x coordinates divided by 2 and then sum of the y coordinates. So we have y1 plus y2 divided by 2. So we get the value 3, y1 plus y2 divided by 2. So let this be number 2. And we can equate 1 and 2 because they are the same coordinate values. So that means we have 3, y1 plus y2 over 2. This will be exactly equals to 3, 7 over 2. They are the same coordinate points. Now 3 equals to 3 because the x coordinate is the same. Similarly, the y coordinate is the same. That's going to give us y1 plus y2 over 2 equals to 7 over 2. Or simply put, y1 plus y2 will be equals to 7. So let this be equation number 3. Now we're going to use the property of a rectangle where the two diagonals of a rectangle are equal in length. That means the length of the diagonal AC will be equals to the length of the diagonal BD. So we know this for a fact. So let's write it down. We know that the length of AC is going to be equals to the length of BD. Now what we can do, we can use the distance formula to find out the length of AC. So that will be, we'll take the square root. Underneath the square root, we need the difference of the x coordinate. So that's 5 minus 1. We square it and then add it to the difference of the y coordinate. So that's going to be 5 minus 2. And then we square that value as well. Similarly, we can use the distance formula to find out the length of BD. So BD is going to be the difference of the x coordinate. So that's 3 minus 3 squared added to the difference of the y coordinates. So that's y1 minus y2 whole squared. So let's simplify this. So we have 5 minus 1 squared, so that's going to be 4. So 4 squared is 16. Then we have 5 minus 2, that's 3. 3 squared, that's going to be 9. So 9 will be equals to square root of y1 minus y2 whole square. Now square root of 16 plus 9, that's actually square root of 25. So to square root of 25 will be 5. So we get y1 minus y2 equals to 5. So actually we have plus or minus y1 minus y2, or we can say y1 minus y2 equals to plus or minus 5. So let this be number 4. So when we solve equation number 3 and equation number 4, then we get the value of y1 as equals to 6 and the value of y2 as equals to 1. Fine. So now that we have the value of y1 and y2, we are ready to find out the equation of the sides of the rectangle. Okay, let's redraw the diagram. So we have the coordinates of point B at 3, 1 and coordinates of point D will be 3, 6. So let's find out the equation of the sides of the rectangle. Now in order to find out the equation of the side, we'll start with AB. We need the coordinates of the endpoint. So because we'll be using the 2-point form of a line. So let's quickly recap the 2-point form of a line. The equation of a line passing through 2 points x1, y1 and x2, y2 is given by the equation y minus y1 equals to difference of the y coordinate divided by the difference of the x coordinate whole multiplied to x minus x1. Okay, so let's use this. We will start with the side AB. So here we will do y minus y1. We'll assume that A corresponds to x1, y1 and B corresponds to x2, y2. So that means y minus y1 will be y minus 2. So 2 corresponds to y1, which is the y coordinate of point A. This will be equals to, now we need y2 minus y1. So that's going to be 1 minus 2 divided by x2, which is 3, minus x1, which is 1, whole multiplied to x minus x1. So x1 will be 1. So now we have y minus 2 equals to negative 1 divided by 2 whole multiplied to x minus 1. That gives us 2y minus 4 equals to negative x plus 1. Rearranging the terms, we get x plus 2y equals to 5. So this is going to be the equation of side AB. Next, we'll find out the equation of side BC. So here we have y minus y1. So we'll take y1 as 1 equals to, we need the difference of the y coordinate. So we have 5 minus 1 divided by 5 minus 3. So this will get multiplied to x minus 3. So solving this, we are going to get now y minus 1 equals to, so 5 minus 1, that's 4, and 5 minus 3, that's 2. So we have 4 divided by 2. So that's going to be simply 2. We have 2 times x minus 3. So let's rearrange the term. We get 2x minus y, and then we have equals to 5. So this is going to be the equation of side BC. Then we can find out the equation of side CD. So CD is going to be, we'll take y minus 5 equals to 6 minus 5 divided by 3 minus 5 whole multiplied to x minus 5. So we're rearranging the terms. We are going to get x plus 2y equals to 15. And then finally, we will find out the equation of side DA. So here we will have y minus y1. So we're going to consider y1 as 2 equals to the difference of the y coordinate x minus 2 divided by the difference of the x coordinate 3 minus 1 whole multiplied to x minus x1. So rearranging the terms, we're going to get the equation 2x minus y equals to 0. So we have successfully obtained the equation of all the sides of the given rectangle.